as well. And yeah, thanks for the really warm reception. So I'm here to talk about Toom and Magento. And first of all, who's heard of Toom? Is it just a big German brand then? Everyone's aware? Because when they came to Invika and I was told, oh, you're going to be working on Toom, I was like, who? I had no idea who they were. But, you know, looking at them, they're a pretty big company. Close to 3 billion euros a year that they take in turnover. I think about 100 million of that is now due to online reservations. And they have about 14,500 employees and also part of the Riva group as well. So I'm sure you've heard of the Riva group. And they have those Riva shops all over the country. And Riva have about 350,000 employees. So again, really, really big company. Now, Toom had what they call 350 markets. This was a new term, again, to me, coming from England. But they're basically the big warehouses. So Toom are a DIY company. They sell home improvement products. And they have 350 of these stores, if you like, that you can go into. And this is actually the largest single brand store network in the entire of Germany. So it's, you know, it's huge. Now each market can have their own promotions, their own prices. So it gets quite complicated when we're translating this business model into Magento. When you would have technical difficulties. Maybe. Shall we jump to the next one? Oh, yeah, thank you. So, the technical challenges on the project. I'm going to restart my keynote here. We had a lot of them. So, the first one I've just talked about briefly, with the fact that each market can have their own their own price, and obviously their own stock. And when Toom came to us at the beginning, they wanted to recreate their whole online platform, which they already had, but was only allowing them to do online reservations. So I'm going to look at that today. I'm going to look at some other things as well, which I think are some of the more translatable, if that's a word, the things that I think you can take something away from. Because a lot of this project is specific to Toom, and there's no point in me talking about Toom's specific business requirements. That's not going to help you on your projects. I really hope that some of the stuff that I do talk about is useful for you. So let's have a look at the first one. The first problem being probably what we thought was the biggest challenge on the project. How do you take Magento's very fixed stock model, very fixed pricing model, to introduce this new concept of a market? Now remember that each market can have its own prices, it can have its own promotions. Obviously, because we're doing online reservations, we need to know what is the stock of every product in every market as well. So we're dealing with quite a lot of data. And the first thing we did, was, you know, look at how we can model these markets in Magento. The first thing that we actually thought of was to model them in Magento with stores. However, when you model this amount of stores in Magento, have 350 stores in Magento, the indexes just start to balloon in size. So we work with Magento Consultancy, and we actually spoke to some of the more senior engineers at Magento as well, because this was a huge project, and we wanted to get it right from the start. And we even prototyping this with Magento stores, it didn't actually even load the admin dashboard, it was that bad. So what did we do? We basically created our own custom model for markets. Now, when you start to add a custom dimension to price and stock, you now need to think about creating your own bespoke stock and price model as well. And this is what a lot of us were thinking on the project at the time. Panic stations, you know, were taking a huge part of Magento, replacing it. You know, when you think about price and stock, they're two of the most core concepts of e-commerce. So as soon as you take those out, you know, you're going to have, or we thought would be a lot of work trying to plug in our stock model to Magento. But actually, it's not that difficult. It turns out when you start, again, I'm not going to talk about how we built a stock model at the very low level for Toom, because a lot of the requirements are specific to Toom. It's their business. It's not going to translate. However, if you're going to do something like this, look how Magento uses its stock registry. And you can use dependency injection configuration, which just allows you to replace certain components in Magento, to replace their registry with your own version, and that's exactly what we did. There's a common interface, so there's an API contract that you can just implement, and Magento is perfectly happy. And then likewise, for price, if you can move the slide, sorry. For price, we have the price pool. And in the price pool, there's various types. You've got tiered pricing, special pricing. And for Toom, they weren't bothered about those features in Magento. A bit of history about Toom, obviously they had their own online platform already. They already had a huge price database, and they had a whole ecosystem of microservices around managing that price data, and likewise for stock. So basically, we just replaced all of the price types in Magento with this new market price type. Later on, we would actually also add in an online price type and also online stock. So we now have our custom price model, we now have our custom stock model, and we now need to start thinking about performance. And Magento has its own indexes for price and stock. And these indexes are basically built in the background. And what it does is it's actually generating something that's more optimized for runtime performance. So when the product page is rendered, we want that data to be available in the most optimum format. And what we did is, because Toom had a very complex way of displaying prices on products, we had an index which specifically just had all of the price information ready to display on the product page. They also had, like I said, a huge array of microservices, and they are a heavily microservice-based company. So when Magento coming in as like a monolithic application, we had to try and make it work with what they had already. And two of these services, or two collections of microservices, were stock and price. And we didn't want to throw those away because they've been battle tested. They've been used in production for 1 to 2 years. They had a wealth of business logic in there. And they also plugged in with the rest of the architecture as well really nicely. So we took those on and we just adapted them to work with our new way of managing data. Now, looking at stock, I think this is more of an interesting one than price. So I thought we'd look at this one in a bit more detail. This is at a high level what our initial solution looked like for stock. So we had the stock services, and we also had Kafka. So has anyone used Kafka before? Okay. So I'd never heard of Kafka until I started this project. And basically it's like a queue, but it has support for real-time event streams. Okay, maybe not. Okay, it's a middleware then. But basically it's a data store, and it can support message streams. They have Kafka at the heart of everything in their infrastructure. And when an item is sold in a market, it makes its way into SAP, and then SAP pushes it out to this Kafka topic. And from there it goes to our stock service, stock importer, and into our stock service, and then makes its way into the Magento database. Now, we made a decision at the start of the project, due to time constraints, to have the stock data living within the Magento database, because that made indexing much more easy. So as we said, Kafka provides real-time updates, and this actually gives us, whilst it's cool, it gives us a very, very big problem. Because if you're getting stock changes as they're happening in the markets, you're going to end up with millions and millions of updates per week. So then it becomes a question of how do you keep your index up to date? So remember, we had the raw stock data, we've got our stock indexes, or stock index, sorry. So what we started with was MView, which is core Magento, and MView, I'm sure everyone's familiar with it, but it basically allows you to just re-index one row when the source row changes. So you have a record, that's for product A in market 2, then when that record updates, we just re-index that record in Magento rather than having to, like in Magento 1, we had to rebuild the whole index. Now we still had nightly indexes, and this was just to keep in sync the Magento index data with the source data, which was the master data of stock. Now when you build huge indexes, there's a really big problem if you're, again, I wasn't familiar with this, but in PHP, if you issue a query, let's say, select star from the stock table, we want to get all the stock records, but I only want to iterate through them one row at a time. Well, by default, what PHP is going to do, and this wasn't explicit, in fact, it's not explicit, it's an implicit thing, is it takes the entire result and it buffers it into your PHP process memory. Even if you not assign it to a variable, it will be in the process memory. So in the case of stock, where you've got 4 gigabytes of data or something like that, you don't want that being buffered into memory. This is called query buffering, and this is what PHP says on that topic. The idea, I think, is to reduce the load on the database server, and yeah, it's really not an ideal situation for us, especially when you've got an index which is running for a long period of time. You don't want to be consuming a lot of memory. So what you can do instead is you can use an unbuffered query. An unbuffered query does exactly the opposite. Basically, the unbuffered query keeps the result on the MySQL server, and then in your PHP, you can literally just get one row at a time. So your memory footprint is tiny. You're talking about 100 kilobytes or whatever to run the PHP process. And to create a buffer query is really, really easy. It's just getting the current connection, setting a configuration option on it, and then recreating a new connection with that configuration. And now what we have is the database is now holding that result for us, and we can, like I said, get each row as we want to. Now, I said earlier the first approach we took to keeping indexes up to date was Enview. What we realized shortly after we launched was that Enview was not really doing the job for us. It wasn't keeping up with the volume of stock changes that we had. At any one time, basically this is what our indexes were trying to do. They were trying to keep up, they just couldn't do it. So at any one time we could have maybe tens of thousands of stock updates just waiting to be processed by Magento. At best, you're going to get a batch of index records updated every minute. But in reality that doesn't really happen because Magento, for some reason, doesn't update every index every minute. It kind of switches between all of the available indexes. So in reality, it's more like every 3 minutes. So what we did is we thought, how can we get these stock changes into Magento in a different way that's not going to cause this huge bottleneck? And what we did is we looked at RabbitMQ, and this plays really nicely with Magento. Magento's got great support for it. A lot of it is just configuration, so we decided to use that. At the same time, we decided we're going to move the stock data out of Magento, because that was a decision we made at the start of the project. It wasn't ideal, and now because we weren't going to be relying on the data being in the same database, because the way we're changing how we're updating our indexes, it was a good time to do that. So this improved the isolation of data. Now we ended up with something like this. So the only way for Magento to get access to the stock data now is through the stock service. And likewise for everything else in the infrastructure. Then we added RabbitMQ. And now what was happening is as that change comes through the sale and it gets updated in the stock service, and it updates in the stock database, we now also published a change to RabbitMQ, and this was just a little message to say, hey, here's the new stock level for this market and this product. And then what we had at this layer here was consumers. I don't know if you can read that, but basically Q consumers, again, part of Magento's AMQP support, and all the consumers do is pull messages from RabbitMQ queues and process them. And what we did is we just took those messages and updated our index with them. They're completely isolated from the rest of the shop because we run them in their own containers. And we can scale them as well, because I think at the moment we have about 20 of those containers running in production. And you can do that to an extent without issues. If you start to go beyond that, you may start getting like locking issues with the table, but we haven't really seen that being a problem for us too much. So the big lesson for us here was indexes are really, really cool, but the problem with the partial index updates, we've seen can't always keep up with the demands, especially for something like Toom, where they have millions of updates a week. So we ended up swapping it out for MQP, like the RabbitMQ solution. And also just profiling as well. The query buffering problem was a result of us debugging in our local and then in our local development environment and trying to figure out what was going on. And it was tideways, I think we used, which highlighted what was actually happening. That entire table was being buffered into PHP, and we had no idea. Also, make sure to use a realistic data set as well, because if in production you've got tens of millions of records and you're trying to index all those records, don't use a data set in local of 1,000. Oops, sorry. Okay, so the next problem was the huge catalog. And this catalog is continuing to grow. As you can see, a huge number of attributes and attribute sets. And the way that data is received by Magento for Toom is through a middleware. So they had a middleware that connected all these different systems, PIM, SAP, and it provided a representation of the product to Magento and said, here you go, here's a product, I want you to create it. Now, if we look at this in a diagram, you see the PIM sends the product data to the Speed for Trade, which is the middleware, and it has to wait until Magento has actually created that product. So it sends it, waits, and then gets a response back. And the problem with that is that it's incredibly slow when you have 100,000 products, and each one's taking about 3 or 4 seconds, and it takes 5 days to do a full catalog import or a full catalog sync. And business like Toom, you can't move that slow. I don't think any business can move that slow. The other problem is that the middleware couldn't send multiple products. It couldn't send concurrent requests. And that was the first thing that you think about. Well, Magento could definitely handle that, but the middleware couldn't. It couldn't do it. So we had to think, again, about how we could speed this up. So we used RabbitMQ again. We wanted to take the requests that were synchronous, like waiting, there was a long wait time, and make them asynchronous, so that all of that processing could be done in the background, and the middleware could send us more data. So what we did is, again, use RabbitMQ, so that when the request for the product was received, we put it in RabbitMQ to be dealt with later, and then we'd send a 202 response, which is basically just telling the middleware, okay, I've accepted that, I've not dealt with it right now, but I'm going to deal with it later on. So this is then how our product data flow looks like. So again, in the request for creating or updating the product, it wasn't actually persisted to the database, it was put in RabbitMQ. And then we had these queue consumers that were basically picking up these messages, trying to create them, and then any errors that we had with creating products, because obviously that can happen, we would store them in a table, and then there was a new API endpoint where the middleware could say, okay, has any products failed to be created, and then they could handle those on a case-by-case basis. But again, we can scale those consumers completely separate to the shop. And the load on the shop is pretty predictable. So, obviously the API response decreased massively. It was 8.5 times quicker to send the same amount of products to Magento than it was before. But the big improvement, I think, was that it was 600% faster to send the same 1,000 products with this new approach, this new async API approach, than it was in the synchronous, which is the native version of the REST API. Now, I think when I first gave this talk, it's at Magento Live, and there was a talk there called, I think it's about the async API, basically, and that's a big community initiative that's really promising, and they're trying to add this asynchronous nature to all of the APIs, or as many of the API endpoints as they can, to try and improve this type of scenario. So I definitely recommend checking them out. So yeah, for us, the lesson was, not be confined by what Magento gives you. Though we looked at what it supported out of the box, things like AMQP, and we thought, how can we use that to make our lives better? So we're still using tools that Magento supports, and yeah, just doing things slightly differently. Okay, so the last major issue that we faced was, how do you do zero downtime deployments with Magento? And the main issue with the deployments from Magento are how database migrations are handled. So how is the database upgraded during that deployment window? And the database migration, I'm sure everyone knows, but it's the way basically of changing your database automatically during that deployment window so that it supports your new code when it goes live. Now in Magento 2.2 and below, the only way to trigger a database change was to change the module version. And changing the module version has direct implications. Because if the module versions are different between your code and the database, then Magento is just going to throw an error because it thinks, hey, you've done something that you should have done. It's not particularly helpful in a production setting, but I can see why Magento have done that. So we looked at how Magento recommended to do deployments, and they suggest using a maintenance page. And for Toom, that was a big no-no. They said, we can't be doing that. We want to release frequently, so the changes that we're doing day to day for our new features, we want to be releasing those once a week, if not twice a week or more. You just can't do that if you're either throwing up a maintenance page or seeing downtime every time that you do a deployment. So we basically looked outside of Magento and we found Finks, and we'd used this, some of us had used this in the past. It's basically just an open source migrations library. It's not tied to any framework, so it's perfect for our case. And we just made a module which integrated Finks and also integrated the usual setup classes that you get, like EAV setup, data setup, and schema setup, into the migration files that you use in Finks. So it's still really familiar for Magento developers. But what we had now was a new trigger. So instead of relying on that module version change, we just had a migration, a completely separate way of actually triggering those. So what did it actually look like? Well, we used the setup db status command first, and that would tell us, is a setup upgrade required? Unfortunately, we're still going to have to run setup upgrade for Magento upgrades, which are a few times every year. And also, if you use a lot of third-party modules, you're going to have to run a setup upgrade as well. That's just an unfortunate side effect of using Magento. What I would recommend is if you do use a lot of third-party modules, try to batch the upgrades into one release. So you can schedule that, even if it's like, when Magento releases an upgrade, you need to get that out. Consider upgrading all of your third-party modules at the same time, so you only have one window where you have that maintenance page up. So yeah, the exit code of the setup db status command can tell us, do we need to run that setup upgrade? Regardless of that, we then run Finks migrate, and this basically just runs all of our migrations, which we're now using instead of Magento's default way of handling migrations. And then we carry on with the rest of the deployment as normal. What we need to be careful of, though, is making the changes in our migrations so that database changes are backwards compatible. During a deployment, it's very unpredictable because if you're deploying new code and you upgrade the database, then your old code, which is currently running and serving the site, is then going to be using this new database structure. So you need to make sure that any change you make to the database doesn't break the code that is already in production. And the way we like to think of it is, if I was, as a developer and I was working on a database migration, if I was to make that database change now in the production database, without deploying new code, would it break? And that's often what we would do. Is the first thing we try to do is make that database change in our development environment and see if anything does break. So remember earlier I thought, this is mainly focused around Magento 2.2. Because in Magento 2.3, they released declarative schema. Has anyone used declarative schema? Okay. So YouTube, anyone who put their hand up probably knows more about this than me. Because I just had to play around with it. It's not something we've investigated much on Toom. We're just about to roll out Magento 2.3. But from my initial tests and looking at it, I think it could replace our migrations approach for zero downtime deployments, because now you don't need to change the module version in order to apply database changes. As we'll see, the schema now is modeled as an XML file, or a bunch of XML files. So let's say you wanted to add a new table in your module, you would have an XML file for the table, you model it as you want to, and then during the next deployment or the next time you run setup upgrade, Magento compares all of the schema XML files to what's in the database, and any differences it applies onto the database. We don't have to change the module version, and we don't have to write SQL statements or use setup classes in order to manipulate the tables ourselves now. We're just saying to Magento, this is what we want our database to look like, and Magento will figure it out for us what needs to happen. So that's really, really promising for me. Unfortunately, I think we're still going to see downtime, and you'll tell me otherwise, but for Magento upgrades, when the module versions change, we may still see that downtime. So it's probably not an all-encompassing zero downtime solution, but it can replace our migrations approach. So once we got past the database changes, we have another problem, and that is the cache. Because, again, going back to what I said before, where you're deploying some new code, and your old code is still serving traffic, then what about the cache? Because if your new code's been deployed and it clears the cache, ready for the new code to start receiving traffic, well, your old code may receive a request and then warm the cache with some old data, and that's going to break your new code when it actually becomes active. So it's a really unpredictable scenario. And this is how it would look maybe if you're deploying, let's say these are Docker containers. We deployed 2 new ones that are currently in the process of being provisioned, and they're applying database changes, and the old code is still serving traffic. But at the moment, these 2 old nodes are the only ones that are active. And as soon as one of these new ones becomes active, we need to make sure that the cache data is ready for the new code and not caching old code. Does that make sense? So all we did basically was add a different Redis database. So it's the same instance. We've just now added a second database inside Redis. You have 2 databases alongside each other. And we have a really simple database script, deployment script, which decides during the deployment what Redis database this deployment is going to use when provisioning the containers and bringing those containers up. So if we look at a diagram, we can now say that it doesn't matter what node, what container takes that request. We can actually have old code and new code running simultaneously, and it will be absolutely fine because the cache data is completely separate. And remember, we don't have the problem with the database anymore because we've made our database changes backwards compatible. Could you come back to you at the end? Is that okay?
Can I skip then? What do you do with a card or with a person they use the card on the old code and then he switch on the new code? What do you do? Because if he is not logged in, he will lost the card in most cases, I think.
No, so the sessions which aren't illustrated on here would be in a different database within Redis, so that's absolutely fine. But yeah, if you've got any questions, we can take them at the end. So yeah, we basically end up in a state where we have zero downtime. For our day-to-day and week-to-week deployments for our own code, we don't have any issues with downtime, which, looking back now, is a big achievement for us because we had no idea how to do this at the start. Maybe other teams are already doing this as well. I think it's something that Magento really needs to get better at. But yeah, it seems to work. It works very well for Toom. So, big takeaway for us was, don't run setup upgrade every single deployment. It's very heavy. It runs recurring tasks which aren't always required, We've actually had issues sometimes because we used to run setup upgrade all the time, and some of the recurring indexing jobs it would do would actually break the deployment. So I would always use the setup DB status, check whether you need to run it before actually running it. And also have a look at declarative schema. That's definitely a takeaway for Toom, and we would definitely have a look at doing that and replacing our migrations approach, because if we can use something that's natively supported by Magento, that's definitely better than using a third-party module. So, but at the end of the project, what did we learn? I think firstly was the fact that huge customization around stock and price was really achievable. It was something that we were really concerned about at the start of the project, but actually didn't turn out to be that difficult. The way we approached it was to prototype things really in a crude way at the start. And we started off with a hard-coded data model, for example. So we had basically in the stock registry, which I talked about earlier, and also in like the price model, we would hard code some prices or some stock levels. And because the user has to select a market in the browser and it's stored in a cookie, we would just demonstrate that by changing your cookie, you could affect the final price on the order. When we had the confidence that was working, we then started to add some dynamic market data, some dynamic stock data, price data, and so on. But every step, we were just, at every point, we were taking baby steps rather than just taking a big leap and then finding out that that wasn't the right approach. So yeah, we've talked about RabbitMQ in a couple of contexts. RabbitMQ is now really critical for us in terms of bridging Magento into the rest of Toom's infrastructure. But things like the catalog import, and obviously we've got the async API community project now, they're ideal candidates for parallelization. Custom indexes, so again we've covered those, but just be wary. I think if we were doing this again, we would have done a lot more upfront benchmarking and profiling of MView, because it sounds really cool and it's sold as though it can just keep your indexes up to date, achieving heading. But yeah, it didn't do the job for us, and we had to replace it with something bespoke. Profiling for us again, that buffered query issue. Profiling indexes and things like that. You can't really replace something like Tideways or Blackfire with var dump. You need to actually get something that's giving you insights into your code. And if you can get Blackfire as part of your workflow, that's even better, because it can tell you on your pull requests before anything's even been reviewed whether you've actually negatively impacted performance on critical user journeys. And zero downtime deployments. For your own changes, your own updates and features, you can, it's definitely possible. You just have to make some trade-offs. It's not possible with Magento upgrades, unless you wanted to start hacking the way that Magento actually does its module comparison, which doesn't really feel right to me. But you can definitely make zero downtime deployments possible, and then you can start to do things like continuous deployment as well. So yeah, thank you for listening. I'm James, and I work for Invika. I work in the Liverpool office in the UK. I'm a technical team lead on the Toom project, and I've been on it since the beginning, which is about 2 years ago, so it's quite a long time. And yeah, I look forward to speaking to you all, and if you have any questions, I'm happy to take them now or after. Thank you. Sorry?
I have two questions.
Sure.
The first one should support the second one. Usually, what is the longest deployment that you have?
So we started, just a bit of background, we started off with Docker Swarm, and we actually migrated over to Kubernetes about 6, 7 months ago. And we've been tweaking the way that we deploy, because with Kubernetes you can control how many pods you're adding and how many you're taking away. But I think it takes about, and some of the guys may correct me, 20, 30 minutes to do a full production deployment. And that's because every deployment we do, we're deploying the actual shop itself, of which we have maybe 4 containers, and then all of the different consumers that we use. So we haven't talked about all of every single queue consumer that we actually use, but there are quite a lot. I think it's about 6 now. So it can take a while.
I I have now another question about the front-end nodes.
Sure.
Do you know more about the front-end deployment and how things stay there?
Yeah.
So what do you do when the load balancer wants to show me one old instance, and then on my next request I see some other, I get response from another instance that is a new one.
Yeah.
Do you try to kind of keep the people stick to one instance, or is there some scheme for this?
That's a really good question. It's not something we suffer from because our front end is decoupled from Magento. So Magento says markup, but we have a pattern library. So the pattern library is maintained as a separate piece of software, and it's served from the CDN. So I think when you go to toom.de and you go to the basket, for example, you'll see that the basket is rendered
So you
dynamically.
have front-end microservice.
No. So basically, all that the front end is a bunch of assets that are served off the CDN. So a bunch of JavaScript and styles as well. The markup, for example, on the product page is rendered by Magento, but in terms of the functionality, like the scripts and things like that, they're managed in the pattern library, which follows semantic versioning, has its own releases. So what we would usually do is deploy the Magento release, and then we can change the style guide version in the admin to a new version if there's one available. Make sense?
Yeah.
Okay. But your is over there. You can tell you more about the front end stuff. You're right. Okay. Any more questions?
In the beginning, you said something that you have so many different countries to serve there. Actually, I didn't get how you then reduced really the size or the amount of catalogs there.
Sorry, so we only serve, it's only Germany.
Ah, okay.
So it's 350 markets. So there's a physical store, like the big warehouses, that's what they call the markets. Yeah. So in terms of, it's the same catalog.
Okay, it's the same catalog, it's
Yeah.
just stock in the system.
Yep. Okay. Thanks again.